loud. Okay, so here's our first set of notes, our first lecture, and it's going to cover fractions and word problems with fractions. So in A, it says, how would you visually depict each of the following fraction operations? So I guess we could say there's not really math involved here. It's just a thought. There is no wrong answer. So for number 1, it's 1/2 times 2/3. How would you guys visually depict? And it could be a real world application. How would you visually depict this process?
I'm sorry, Professor C. I'm not really understanding the question. What do you mean by depict? Like,
I guess like, because it's kind of out of the box thinking, like, where do you think you would see such an operation? Like, where do you think you would multiply fractions?
Like in real life?
Yeah. You're like, nowhere. We don't do this.
Yeah, I'm like, I don't know.
I agree.
No, it's good. Yeah.
Maybe cooking? I don't know.
Good. Yeah, good. Cooking's a great one. We could probably do that for all these examples. Right? Let's say, because what it might even be even better. So this is what's great about math, right? And calculators. You could even change these to decimals, right? You can make this 0.5 times, what's 2/3? 0.66 repeating, right? We'll just say 0.67. So I would say, yeah, cooking's a great answer. You could say, hey, I need half of this 0.675 recipe. So you would do 0.5 times 0.67. And like I said, we're not doing any math. We just want to know where we would see it. So I'm just going to say here, cooking. Perfect. That's what I was looking for. That's it. That's what this question was actually looking for. And I'm not going to lie to you either. Somebody rewrote this packet and I haven't seen this one before, but I thought it was fun. All right, cool. So number 2, 1/6 plus 4/6. What else do you guys think?
5/6?
It'll be 5/6, but again, we don't want to know the answer. We just want to know, hey, where in the real world would you see something like this?
Like when you're,
Maybe if you're like buying something at the store, you have to, I don't know, never mind.
No,
or slicing a pie.
slicing a pie, some pizza, right? I guess we're back to cooking, right? How about we change it up and say baking? How about also somebody said like shopping? It could be going to HEB and confusing the crap out of the butcher. I need 1/6 pound of that steak over there. And they probably wouldn't do it for you. Okay, good. So these are just something to throw out of, it's crazy, out of left field fraction questions, right? And then number 3, 5/8 minus 1/4. I mean, if we just want to go, oh, actually, I got a good one, right? Here, let's do this. Bam, how's that?
That's
Right?
perfect.
There you go,
That's the best
cocktails.
one so far.
Hey,
Now
this
you got my
drink,
attention.
there you go.
Just kidding.
Hey, this drink would be better with a quarter less of this ingredient. How's
Are
that?
we gonna get some in this class or?
No. Normally at the end of the semester, maybe. Sometimes I used to do it after the final exam. I'd be like, hey, who wants to go hang out at this bar? And sometimes it happened, but not anymore, guys. All right, cool. So that was just a little fun activity. I actually like that one. That was like out of the box thinking. All right, but now the real fun starts. Now we want to perform operations on these fractions. So let's start with number 4. Okay, and I'll zoom in a little bit. There we go. All right. And it's okay if you're a little shady on fractions or you hate fractions. Hopefully, by the end of this lecture, you'll eat fractions for breakfast. Okay. So number 4 says 4/9 times 3/16. So whenever you multiply fractions, you multiply them straight across. Well, before we do that, we can do a small operation called cross cancelization, right? We can cross cancel. So instead of multiplying those two numbers, why not cancel some terms? So we see 4 and we see 16. The greatest common factor between those is 4. So if I factor or divide a 4 out from 4, I get 1. If I factor or divide, same thing, a 4 from 16, we get 4. And if you need to see that in another light, I'll just write it to the side here. What we did was say 4 over 16, and then I'm going to break this down into factors. So 4, I'm just going to write as 4 times 1. 16, I'm going to write as 4 times 4. And we see that now I can cancel those 4s. And that leaves me with the 1/4, exactly what you see over there. All right. And then let's do it with the 9 and the 3. You have 3 over 9. They have a common factor of 3. So if I divide a 3 out from 3, you get 1. Divide a 3 out from 9, you get 3. And once again, I'll show it again what I just did. I had 3 over 9, and that's going to be 3 times 1 over 3 times 3. Cancel those, and you're left with that 1/3, just as you see up there, 1 and 3. Okay, now I'm just going to rewrite what we have left to be neat. So what we have left is 1/3 times 1/4, 2 much nicer fractions to work with. And you multiply straight across, and you're going to get 1 over 12. Everybody good with that?
Yes.
All right. Let me maximize this screen. There we go. Gives me more space to work with. Okay, perfect. All right, let me move over to the right a bit. There we go. There we go. Nope. You stay there. All right. Now number 5. You have 7/8 divided by 2/9. So whenever you divide fractions, you must take the fraction on the right and do what with it?
Do the reciprocal.
Good.
Flip it.
All great answers. So you will multiply by the reciprocal, or since students don't like to say reciprocal, they like to say flip. You combine both words and you multiply by the flippercle. How's that? You're like, yeah, whatever. All right. So we multiply, get that off, by the reciprocal. So this becomes 7/8 times 9/2. So we
So it's
multiply by the reciprocal. Go ahead.
The dot flip method, is that?
Exactly. Okay. And then, so we reciprocate, we flip the fraction on the right, and then we multiply straight across. We do want to look to see if we can cross cancel, but 7 and 2, nothing in common. 8 and 9, no factors in common. So this means that we are just going to multiply straight across. And we're going to get 63 over 16. All right. Everybody good with that?
Yes.
All right. And also, if you want to say you're good, you can do the thumbs up and I'll see it in the chat. All right. Another way to remember this method is the way I like to say it. So whenever you divide by a fraction, we know that you multiply by the reciprocal. So what we do in this process is we keep the first fraction And then we flip the second fraction. And then the last thing you do is you change division to multiplication. Hey, look at that. Threw a KFC commercial in there. Keep, flip, change. Let that stick in your brain, right? Who's hungry? All right. Number 6. All right, here we go. You have 21 over 24 times 16 over 18. So here, once again, we want to find a common factor, the greatest common factor in two numbers. We don't want to multiply these fractions straight across unless we really have to. So cross canceling is the best idea. So we look at 21 and we look at 18. Anybody know the biggest number I can take out of there?
Is it 3?
3. Very good. So I'll take a 3 from 21. You get 7. I'll take a 3 from 18. You get 6. Okay. And then we look at 24 and 16. What's the biggest number I can take from there?
8.
8. Very good. Oops. All right. So take an 8 from 24, you get 3. Take an 8 from 16, you get 2. Let's rewrite what we have. 7 thirds times 2, 6. And actually, we can reduce this to 6. Anybody know what that reduces to?
1 over 3?
1/3. Good. So this becomes 7 thirds times 1/3. And now we multiply straight across and get 7 ninths. Beautiful. All right. Excellent.
All right. Sorry, Professor. Can you
What's up?
show me how you got 7 thirds? I thought we were just going to multiply 7 times 2 across.
7 times 2 across.
Mhm.
Okay. Like from this step to this step.
Mm-hmm.
Okay, cool. So what we did was, once again, so remember we're cross canceling, right? So here, I'll write that here. So what we did first was find a common factor in 21 and 18. So these two numbers when we cross cancel. And we found out that biggest number happened to be 3. So I can rewrite 21 as 7 times 3 and 18 as, what did I write it as? Oh, 6 times 3. So yeah, so 6 times 3. Okay, so these cancel, and that leaves me with that 7, 6. Does that part make sense?
Yes, I'm sorry. It's been a long time, and I used to be good in math in high school, but it's been like 20 years, so I'm just, it's all coming together.
No, you're fine. I mean, you most likely are not the only one in that boat. Trust me. Probably more of these students do not like fractions. Okay. And then to show you where that 7 thirds comes from, well, we had 16 and 24 as well. So these two numbers, 16 over 24. So if I broke those down, we said that 8 was the biggest number. So 16 is 8 times 2. 24 is 8 times 3. Cancel those, and you're left with the 2/3. That's what you see right there. And then what I did was take these reduced fractions and put them right here. And what we did from here was reduce this to 6 into 1/3. And then we multiplied the fractions.
Do you have to reduce it?
The 2, 6, no, but then you would eventually reduce the final answer. Because if you multiplied these two together, you would get 14 over 18. And what is the smallest number they have in common? 2. And here, I'll write that. If I did 7 times 2 and 9 times 2, cancel, and look where we are again.
Thank you.
You're welcome. That was a good question. Very good. All right. All right. How we doing, guys? Good. All right. All right. 1 thumbs up, 2 thumbs up. I like it. All right. So we're still working. We got fractions. And my gut feeling says I can't skip any of these because we need it, right?
Professor, one more question.
What's up?
So on the last problem we just did where you did all that, you know, multiplication and all that work. So my answer was 14 over 18, and then I just reduce it with the 2 and then simplify it. So is it necessary to do all of these little steps that you've just done?
Like, are you saying you multiplied like the 21 and the 16 first, or you were here and then multiplied?
I was where you put you find the common denominator, or the, I'm not sure what the terms
Other
are.
common factor. Yeah.
Yes, from right there, that's where I just multiplied and then reduced it.
Okay. No, once again, you can multiply them and reduce. And as you see, we still get to the same answer, right? There you go. So yeah.
Okay.
So
Perfect.
again, there's multiple methods to math as long as we get to that same answer. So the way I teach is I'm going to show you guys step by step by step. I really don't skip steps. So, but I will show you as in the process, like I will tell you sometimes like, hey, we can actually skip 2 steps and then get there, but it's all good. Okay. Number 7 is just like the one above it, number 5. You have 4/9 divided by 42 over 18. So once again, we need to take the fraction on the right and multiply by the reciprocal. So we KFC this thing. All right. So this will stay 4/9. And now division becomes multiplication, and you get 18 over 42. Okay. And now let's see if we can cross cancel again. Look at 9 and 18. What's the biggest number they have in common?
9.
9. Take a 9 out, you get 1. Take a 9 out of 18, you get 2. All right. Look at 4 and 42. What do you think the biggest, or I guess smallest number you could take out?
2.
2. So divided 2 from 4, you get 2. Divided 2 from 42, you get 21. All right. I'm going to rewrite our fractions. We're left with 2 over 1 times 2 over 21. Now multiply straight across, and you get 4 over 21. Okay. Any questions so far on 4, 5, 6, or 7? Nope. All right, let's keep moving then. Oh man, how many? Boom, boom, boom. Okay, we're working. We don't have to finish this all today. There's no rush. Okay, starting with number 8. All right. Good for now. That's right, Luis. Good for now. All right. So 8 is 4/5 times 1/8. So we want to multiply these. And again, we see that there is 2 common numbers, the 4 and the 8. So we can cross cancel those. We know that if you take a 4 from 4, you get 1. 4 from 8, you get 2. What this leaves us with is 1/5 times 1/2, and multiply straight across, and you get 1/10. All right, that one was easy, right? Okay. Now we step it up a bit. 1 and 4/9 divided by 2 and 1/4. Oh boy. So we know we need to change from division to multiplication, but what else do we need to do here, guys? What do I need to
You need
do
to
with
change those to a mixed number.
reduce.
Good. Change them to a mixed number. So let's look at this. 1 and 4/9. How do I change that to a mixed number?
It's been a while, but I'm gonna guess.
Like,
Multiply it by the bottom and add the top.
yeah,
Yes.
1 times 9 divided by 4.
4.
Not divided, but
Oh, I'm sorry. Yeah, times.
Less.
10. Okay, good. So you guys know the shortcut fraction trick. Marvelous. So what we say is 1 times 9 is 9. And then we say 9 plus 4 is 13. So what this means is that 1 4/9 is also 13/9. So say it again. 1 times 9 is 9. 9 plus 4 is 13. And you put it over the same denominator of 9. And just to show you why this fraction trick works is how mixed numbers work. So 1 4/9 is also written as 1 plus 4/9. These mean the same thing. But what I'm going to do now is change this 1 into a fraction. I'm going to make it 1/1. You can make any number a fraction as long as you put it over 1. And then I'm going to multiply by that common denominator of 9. So I multiply by 9/9. And this gives me 9/9 plus 4/9. And since I have the same denominator, I can add the numerator, and that's going to give me my 13/9. Now, seeing all of that, how much more do you appreciate this shortcut fraction trick? Or you're just like, I don't like fractions in general, right?
You almost threw me off. But yeah.
I know, me too.
All right. Hey, I'm showing you guys how you're able to use the fraction trick. So you know the trick, but do you know why you're able to use that? And I just showed you why.
I'm very grateful for that trick.
Okay. So, I mean, we're not done yet. We just converted that. So we just converted 1 4/9 to 13/9. And now we need to convert 2 1/4. So I'll write that here, 2 1/4. So we do that same process. 2 times 4 is 8. 8 plus 1 is 9. And we get 9/4.
Over 4.
Okay, so now here's what I'm going to do. I'm going to rewrite it now. So this is now, I use the black pen. This is now 13/9 divide 9/4. And now we need to flip and change the sign. So 13/9 times 4/9. Good. And now we see that there are no factors in common. 13 and 9, nothing. 9 and 4, nothing. So now we multiply straight across. All right. What's 13 times 4?
Is there a trick to find the common factor?
Yes, I would definitely make a factor table. I'll show you how to do that in a second. All right. So I think this is what, 52/81, guys?
Yes.
Okay. All right. So let's look at that. Common factors. So what's a good one above? I think, look at this example, 21 and 18. All right. We want to know, like, what's their common factor? So 21, it's all about knowing how to break a number down. 21, well, we know the only two numbers that go in there, 7 and 3, right? 18, we know there could be multiple breakdowns. I can first start off 18 with 9 and 2. And we don't see any numbers in common here yet, right?
Mhm.
So that means I can break it down one more time, 3 and 3. So now we see a common factor. So what we did in that problem above, we said the greatest common factor from 21 and 18
Was
happened to
3.
be 3. So that is just something you would
Okay.
do with breakdown. Yeah.
Okay, thank you.
Yeah, for sure. Now for common denominators, it's definitely different, which we'll get into in a second. Okay, everybody go with 8 and 9?
Yes.
Yeah. All right. You good, Marissa? No more confusion? And she's like, I'll just use the fraction trick. Good. All right. So now number 10, 1/8 plus 2/5. In order to add two fractions, you need the same what?
Common denominator?
Common denominator. All right. So here's 8 and here's 5. What is their least common multiple?
4, 8, and 5.
So 8 and 5. What's our least common multiple? Now, like I said, for getting a common denominator, here's where it gets tricky.
40.
I was gonna say 40.
Good, good,
Cool.
Barbara. 40. So if you guys don't know, like I'll show you real fast. You would have to start slow. 8 times 1 is 8. 8 times 2, 16. 8 times 3 is 24 until we got to that 40, right? 8 times 5 is 40. You would do the same with 5. 5 times 1, 5 times 2, 5 times 3 until you got to 5 times 8 and you'd get a matching number of 40. Sometimes this is what you have to do if you don't understand how to get a least common multiple. And I recommend doing it if you are terrible at multiplication. It just gets you much faster. So that is just something you'd have to do. Another trick into getting common denominators, well, one other trick that works all the time is just multiply 8 times 5. Multiply
gonna
those two
say that.
together.
Okay.
That's it. Good. Multiply them together and you get 40. All right. So that's what we're going to do. So we're going to multiply each denominator to get them, each fraction to get them to 40. So what I'm going to do is multiply 2/5 by 8 over 8. And I'm going to multiply 1 over 8 by 5 over 5. All right. And this is going to give me 5 over 40 plus 16 over 40. We now have the same denominator. That means you add your numerator and you get 21 over 40. There it is. Okay, perfect. Okay, so next, number 11, 7 3/5 minus 1/2. What do we have to do here, guys?
Convert the mixed fraction.
Okay,
Alright.
we'll start. Yeah, we'll start with that. Let's, get rid of that and go here. So let's convert. So 7 times 5 is 35. 35 plus 3 gives me 38 over 5 minus 1/2. Okay, cool. Now we want to convert. No, we don't want to convert. Sorry, we want to combine these two fractions by subtraction. And just like addition, you need the same denominator. What is the least common denominator between 5 and 2?
10.
10. Good. So in order to get to 10, I multiply 38 over 5 by 2 over 2, and I multiply 1/2 by 5 over 5. And 2 times 38 is, what is that, 76? 76 over 10 minus 5 over 10, and we are left with 71 over 10. All right, cool. All right. Any questions on those ones? 10 and 11.
No.
All right. Number 12. Just like the other two. 5/9 minus 1/6. We need a common denominator. What is my common denominator between 9 and 6?
54.
Good. It can be 54, but in this case, we can think smaller. So when we say common denominator, we want to say like least common denominator.
3.
Well, that would be a multiple, not a common denominator. Or actually, no, not a multiple. That would be a factor of both of them. So here, make those lists like I said.
24.
18. 9 times 1 is 9. 9 times 2 is 18.
Oh,
And then
yeah.
you guys see it. 6 times 1
Yeah.
is 6. 6 times 2 is 12. And 6 times 3 is 18. And that's where we stop.
Okay.
Our least common denominator, our least common multiple between 9 and 6 is 18. So actually making this list can help you because it tells you what you should multiply the fraction by. So 5/9 needs to be multiplied by 2/2. 1/6 needs to be multiplied by 3/3. There you go. Okay. And then you get 10/18 minus 3/18. And we get 7/18. Yeehaw. All right. 13. 2/9 plus 2/3. What is our common denominator here?
Is it 9?
9.
It's 9. So I only need to change which fraction?
The 2/3.
The 2/3. Good.
I mean, to multiply that one.
Good. Yeah, we only change the 2/3 and I multiply it by what?
3.
3. 3/3. 2/9 plus 6/9 gives us 8/9. There you go. All right. Any questions on those four? 10, 11, 12, or 13? And
No, but practice makes perfect.
it does. And it is okay if you are super shady, super like you. This is a refresher for you guys. So work at it. If you have questions, ask. It's okay if you forgot how to do fractions, but at least by the end of this lecture, you'll start liking them. Maybe. Okay. I mean, we have 1 minute left, so this is where we'll stop. But I do have something for you to ponder on, which is really cool. So whenever you guys get common denominators, what number are you actually multiplying by? Look at this.
What do you mean?
So whenever you get a common denominator, you're multiplying by a very special number. Good, Fritz. So 3/3 happens to be 1. Anytime you get a common denominator, you're always multiplying by that special number of 1, because 1 can be anything. 1 is any number over itself. So that is something to think about. Whenever you were taught to get a common denominator, you just knew it as that process. You knew it as, hey, I need a common denominator. I'm going to multiply by this over that. Just know that that process is special and it's called a manipulation by 1. 1 is a very powerful number. Okay, that is my spiel. All right. Okay, and then, oh yeah, let me do that. And that's it, guys. We are done for the day. We only go to 8:15, but I am willing to stick around, help you out with anything, answer any questions you may have.